It's a bird. It's a plane. No, it's someone with curls. It's Math Girl. Okay, we're going to be doing polar coordinates. So, for most of you, what you've learned so far in your graphing is rectangular coordinates. Rectangular coordinates are in the format of XY, and they're on a Cartesian coordinate system, x-axis, y-axis. So it's like we have this point up here, and it has an x-coordinate and a y-coordinate. Okay, what we're going to be learning today are polar coordinates, and they're going to be in the format of r, theta. You will know the difference between a polar coordinate and a rectangular coordinate. Rectangular coordinates are numbers. In polar coordinates, your second number is a degree. It will be an angle. It will be either in a degree or radian units. And so that's how you know if it is a polar coordinate. Okay, let's take that we have this point here and it's got some xy coordinate. We can draw a line from the origin to that point. Okay, then we can draw a right triangle because we went over some from the origin. We went over some x distance and then up some y distance. That turns out to be a right triangle. That is your x distance, that is your y distance. Okay, so in our right triangle, this is your hypotenuse, and we're going to label that r. That is r standing for the radius, because if this is like the center of the circle, if we drew this into a circle, then that would be like the center of the circle, and therefore this would be the radius. So, but that is our hypotenuse. So you can see that we're going to be getting our hypotenuse, or r, using Pythagorean theorem. Okay, so also this angle right here is theta. We can use trig functions, sine and cosine. If we know our x value and we know our y value, then we can use tangent to determine theta, and going backwards, if we know our r value and our theta value, we can use sine and cosine to determine y and x. Okay, so for now we're just going to work on graphing. If you've been given a polar coordinate, which is your r value, which is your hypotenuse, and a theta, how do you graph that? In a minute we'll be working problems on going back and forth from rectangular coordinates to polar coordinates. So for now, let's just work on graphing polar coordinates, looking at 16b1. Again, I know that this is a polar coordinate because it has a degree. It has an angle there. It's either going to be in degree units or radian units. And so, as a polar coordinate, this is my r value, this is my theta value. So how do we graph polar coordinates? You will have a graph that looks like this. Notice we still have our x and our y axis on here. All we now have is we have circles, and because we can use those to count out our radius. Okay, so we're told that our r value is 4, which is our radius. So we can start out at the origin and then count out 4 rings. But we need to put that coordinate, or that point, at 330 degrees. Okay, which quadrant is that going to be in? That's going to be in quadrant 4, because it's a positive angle, so that means we are rotating in the counterclockwise direction. So we're starting at 0, and then we're going to go around to where we're at 330 degrees. So that would be somewhere in quadrant 4, about right here. So we can go here and then count out 4 circles. 1, 2, 3, 4. And this line right there would be about 330 degrees. So it means we started at 0 and we went around, and that rotation around would be 330 degrees. So this is, we can graph it that way. You're determining the angle. I like to look at the angle first, and then you can count out 4, it's like you're going out 4 units for your radius. Okay? And with these graphs you can count out to the 4th circle. 1, 2, 3, 4. So if you look at your instructions, the instructions actually tell you, or say that you're going to write this 3 different ways. We're going to write these coordinates 3 different ways. Okay, actually there's going to be a number of 4 total ways you can write this. They've already given you 1. We can write it a different way. Okay, so we have this line right here, and starting at 0 and rotating counterclockwise was 330 degrees. Well, now what if we rotated clockwise? So that would be this blue angle right in there. So going clockwise, starting at 0, then what angle would that be? If this all the way around is 330, how many degrees are in a circle? 360. So if that's 330, then what is left would be 30 degrees, but we are rotating in a clockwise direction, so we can also write this coordinate as 4, but a negative 30 degrees. We still are out 4 units for the radius, but now we're rotating in a clockwise direction in a negative 30 degrees. That would still put us in quadrant 4. So we're going to write it 2 more ways. How else do we write it? Well, I'm going to come over here without my circle rings, so it's not so cluttered. So here's what I have so far. I've got this point that's about right here, and that's out 4 radius, 4 units for a radius, okay? And so from 0 going in the counterclockwise, we run around 330 degrees, which also means that here, that would be a negative 30 degrees. We can also shoot this straight back, and I'm making this with a dashed line. We're going to shoot that straight back in that direction, okay? Going back to rectangular coordinates, if I wanted to do the coordinate 3, 4, rectangular coordinates, that meant I'll go in the positive direction for x3 and then I went up 4. Okay, what if I wanted to do negative 3, negative 4? This negative just tells me the direction. Negative tells me I'm now going to the left in the x direction, and then the negative y tells me I'm now going down. Okay, because these negatives tell you you're going in the opposite direction. Here, negative meant the opposite direction of this x value. This negative meant the opposite direction of that y value. Okay, so positives in our x and y coordinates were to the right and up, negatives were to the left and down, which these are just opposite directions of what we went there. Okay, now we're also going to be dealing with negatives in polar coordinates, and negative just means the opposite direction because that's what it means in rectangular coordinates. Positive x means to the right, negative means opposite of right, which is to the left. Okay, so this is now going in the opposite direction, straight the opposite direction, so we're going to label it as a negative 4 because we are just going in the straight opposite direction. In x and y, we are dealing with right. Opposite of right is straight to the left. Here, we just need to go straight opposite direction, a straight line. So we're just going to go straight in the opposite direction with a straight line. Okay? If this angle is 30 degrees, so we need to determine what angles these are at, what this is at. If this is 30 degrees, this angle right here is also 30 degrees because they're vertical angles, and vertical angles are congruent. But we don't want the angle, we don't want this angle, we want the angle starting at 0 degrees. So we are really wanting that angle starting at 0. So if this is 30, this angle and this red angle are supplementary angles. So if this is 30, what is this angle? That's 150. And that is our angle going in the counterclockwise direction. So that would be 150, but we can also write this another way. We're still looking at our negative 4 radius because it's going in the opposite direction. Here we looked at the counterclockwise angle. Now for this one, we can do the clockwise angle. So now we're not looking at the 150, we are now looking at that one going that way. Okay, so if that is 150, what is this angle? It would be the other side of the circle, 360 minus 150. That would be 210 degrees. And that would be and negative, that negative tells you which way you're rotating. So let me show you the pattern. For all of these problems, you will be able to write your coordinate 4 different ways, and they all mean the same. Well, these two are representing this point. These two are representing this point. And they actually mean all the same thing. Okay? We call these the real point, and this is, we're calling it, just to be funny, the fake point. So, and I'm always drawing my negative radius with the dashed line because it's like the fake one. This is the real one, and we're always interested in doing any kind of calculations with the real one. But if you look at a pattern, then in your radiuses, you will have a positive, positive, negative, negative. Then for each one, you will be doing the counterclockwise direction, clockwise direction. Counterclockwise direction, clockwise direction. So you're doing, it's like a pattern. Okay, we're looking at 16b3 now. So we have -3, 2 pi over 3. We know that this is in polar coordinates because we're given an angle here. Whenever you're given an angle here, whether it's in degrees or radian format, it's a polar coordinate. Okay? I like to always turn these radian units into a degree unless you have memorized on the graph where all your radian units are on a graph. So 2 pi over 3, multiplying it by this conversion factor, then that's 120 degrees. We did that in lesson 15. So I just make a note here that that's 120 degrees. For your r, for the radius, whenever you graph it, a negative number always needs to be graphed with a dash because that's like the fake radius. And we usually want to look at the real radius. So I'm going to graph this, and since it's a negative, I'm going to graph it with a dashed line. Okay? So I'm at 120 degrees, that's quadrant 2, and I'm going to go out 3. So 120 degrees is somewhere here, 1, 2, 3. I'm out 3 units, and 20 plus, okay. And I'm going to draw that with that's a dashed line. Doesn't really look like a dashed line. Okay, that's a dashed line. So what I have here is that right there is 120 degrees, but I can write it in another format. I need another set of parentheses that has a -r. This was going in the counterclockwise direction. I need the other angle going in the clockwise direction. I need the angle going from 0 to my line, but in the clockwise direction. If this is 120, what would this other part of the circle be? It'd be 360 minus that. So 240. Make sure, yeah, that'd be 360. The reason I'm writing it down there is because when they give radians, your answer needs to be in radians. I'm not going to write the degree. I need to turn this into radians. So off to the side, if you need to do 240 degrees, and so then this is going to be 180 degrees, pi, those zeros go away. I can reduce those both by 6, so then that would be 4 pi over 3. So then I know this is the same thing as 4 pi over 3. So I'm going to take that away. Okay, I still need to be able to write my answer 2 more ways, because you have to write it 3 more ways. Well, since we're dealing with the -r here, these 2 will be with the positive r. Then one will be in the counterclockwise direction, the other will be in the clockwise direction. Okay, so to not crowd my graph up, I'm just going to redraw this. So what I have here, my original problem was this, and I am exaggerating this. That might be out more than 3. This is the original. Now I need to do the solid line. So how do I get the solid line? I shoot this straight back, a straight line. So 180 degrees opposite of this, because that's what negative means. When you want to go in the opposite direction on a graph, you go the exact opposite direction, 180 degrees in the opposite direction. So I want that line right there. Okay, so this was 120, which meant that was 30 degrees. So that means that this right here, make sure you mark your vertical angles correctly, it means that's 30 degrees, but we always want to go from 0. Okay, we're going to go from 0, so we really want that angle right there, starting at 0, going that direction. That would be our clockwise direction, so that angle right there would be negative 60 degrees. So that is one of my answers. It doesn't matter which one you do first. That was my clockwise direction. Clockwise is always going to be your negative. So now I need the counterclockwise direction, starting at 0, going in the counterclockwise direction. I need that. So if this piece is 60, then going in the counterclockwise direction, that whole angle would be 300, because there's 360 degrees in a circle. So this is the 4 different ways of being able to write those coordinates. See the pattern. 2r's will be negative. 2r's will be positive. This needs to be a positive 3. 2r's will be positive. On your 2r's that are negative, one angle will be in the counterclockwise direction, one will be in the clockwise. Matter of fact, that needs to be a negative. So if you go back and check, one's a positive, one's a negative. One's a positive, one's a negative. Counterclockwise, clockwise. What's wrong with these answers? If your problem is in radians, your answer needs to be in radians. So I need to convert these to radians. So 60 degrees. I'm just going to do this real quick. I'm pretty sure it's pi over 6. But 180 degrees, pi, those zeros cancel. Can reduce those by 6, so it's going to be pi over 3. So that's going to be, because that will be reducing that by 6, reducing that by 6, that would be pi over 3. So negative 60 degrees is the same thing as negative pi over 3. Now we need to change 300 degrees. 300 degrees. The zeros cancel. Now we're reducing 30 and 18. I know I can reduce them both by 3. That would be 10 pi. Reducing that by 3 is 6. I can reduce again by 2. So that would be 5 pi over 3. So this one, and it's a positive, 5 pi over 3. So the pattern is, both R's are negative. One of these should be positive, one should be negative of your angles. Both of these are positive. One angle should be negative, one should be positive. Okay, we're looking at 16C12. We have a coordinate here. What kind of coordinate is that? Rectangular. How do you know? Because there's no angles. So that is an XY coordinate. The instructions on this problem are to change these rectangular coordinates into a polar coordinate. So right now it's in an XY format. We want to change it into an R theta format. Okay, so the first thing I'm going to recommend is to graph it. 6 square root of 2. If you don't know where that is on the graph, which I don't, I'm going to change it into a decimal. So do the square root of 2, then multiply that by 6, and that came out to, I'm rounding, 8.5. Okay, now 2 square root of 6, do the square root of 6, then multiply it by 2, and that came out to a negative 4.9. Okay, so now I can graph that point. So going over 8.5, somewhere right in here, and down about negative 4.9 is somewhere close enough to there. Okay, so I've got this point of 6 square root of 2, that was my x direction, and then negative 2 square root of 6 in my y direction. So I can draw this line, I can draw a line from the origin to there. Okay, then I can also draw a triangle to represent that. And this is my, going that way would be my x distance. I went 6 square root of 2 in my x direction, and then I went negative 2 square root of 6 in my y direction. Okay, I don't even have to have that negative, because I know that I went down. Okay? The negative just tells me the direction. It doesn't tell me the distance. And that is a right triangle. To go straight over in the x direction and then go straight down, that is a right triangle. Okay? So I am looking for r, and I'm looking for theta. So I'm looking for this angle. R. How can I find r? Pythagorean theorem. Okay, it's a right triangle, so how do I find the hypotenuse? Pythagorean theorem. I'm going to use the radicals. Using the radicals to find the hypotenuse is the most accurate way instead of rounding these to decimals. Okay, so Pythagorean theorem. If I wrote it, there's leg squared plus leg squared equals hypotenuse squared. In our case, it's an x and y. X squared plus y squared equals r squared. Okay, because this is my hypotenuse. So my x is 6 square root of 2 squared. My y is 2 square root of 6 squared equals my hypotenuse squared. 6 square root of 2 times 6 square root of 2. I'll just write this out the long way. That's what that means. Plus 2 square root of 6 times 2 square root of 6 equals r squared. Numbers to numbers and radicals to radicals. Square root of 2 times square root of 2 is just 2. Because square root of 2 times square root of 2 is square root of 4, and square root of 4 is 2. 6 times 6 is 36. And then 36 times 2 is, because basically what I had was 36 times 2. Well, that is 72. 72, 36, and 36, 72, okay? Plus 2 square root of 6 times 2 square root of 6. The square root of 6's times the square root of 6's is 6. 2 times 2 is 4. 4 times 6, 24. So 72 plus 24, 98 is r squared. Then we got to take the square root of that. Actually, that would be 96. Take the square root of both sides. So r equals square root of 96. Can we simplify that? I'm going to put it into a decimal too. So that is roughly 9.8. Square root of 96. Okay, we can simplify that into square root of 16 and square root of 6. 16 times 6 is 96. So that would be the same thing as 4 square root of 6, which is roughly, what I said a minute ago, 9.8. But we're going to leave it in radical format. So we already know r equals 4 square root of 6. That is part of my turning it into a polar coordinate. I need to know r, but I also need to know theta. Okay? So I'm going to call this theta, although this is not the final answer we're wanting. Theta. How can I find this angle right there? I know this side, I know this side. Well, we know that tangent theta is opposite over adjacent. So 2 square root of 6 over 6 square root of 2. Yes, you can turn those into decimals. So it turns out that tangent theta is comes out to 0.5774. Taking the arc tangent to solve for that angle, 30 degrees. If you used the decimals, you probably wouldn't get this exact 30 degrees. So this angle is 30 degrees, okay? We're wanting the angle from 0 degrees, from 0. So there are several different ways that you can say this answer. If you're going to use this angle right here, then you need to be saying you're starting at 0 going that direction, going in the clockwise direction. If you do that, you need to label that as a negative 30. In other words, okay, our r, we said was 4 square root of 6 and we can label that as negative 30 degrees. That is one possible way to write your answer. Or you can write as 4 square root of 6, but if you want to use the counterclockwise angle, you're coming from 0 and you're going all the way around that way. Okay, so if you start at 0 going in the counterclockwise direction, if this is 30, all of this would be 330 degrees. So you can write it as 330 degrees. These answers mean the same thing. This is just going in the clockwise, this is the counterclockwise. They will get you to the same place on the graph. They both represent this unit of radius at this angle, which are both in quadrant 4. Okay, now we're doing 16D5. The instructions for this, well, we're given a coordinate. What format is that put in? This is in the format of r theta. How do I know? Because that's an angle. It's in radian units, and whenever you have an angle here, that's r theta format. The instructions say to put this into rectangular coordinates. So we want to convert this into an x and y coordinate instead of r theta coordinate. Okay? So the first thing I recommend is to graph this. So here we have negative pi over 6. What does that negative mean? That's the direction you're rotating. That's in the clockwise direction. Then you need to know what is pi over 6. If you're not sure, go convert that into a degree. And I will tell you that that is 30 degrees. Okay, that is the same thing as negative 30 degrees. What quadrant am I going to be in if I'm negative 30? Negative means I'm going in the clockwise, starting at 0, go clockwise 30 degrees. That puts me in quadrant 4. So that is somewhere in here. And I want to go out negative 6 units of radius. How am I going to graph the negative when it's a radius? A dashed line. That's like the fake one. So coming out here, and I'm just going to estimate where I'd be at if I was out 6 circles. So we're going to call that a negative 6, and this would be going in the clockwise direction, 30 degrees. I don't have to write negative 30 because that arrow tells me I'm going in the clockwise direction. Okay? We don't want the rectangular coordinates of this. We don't want the rectangular coordinates of the dashed line. We want the rectangular coordinates of the solid line, the real line. So we need to shoot this line straight back in the exact opposite direction, 180 degrees opposite. And this point is what we're wanting the rectangular coordinates for. Okay? So if this angle is 30 degrees, then that angle is 30 degrees. Because they're vertical angles, and vertical angles are congruent. So now I can draw me a right triangle here, because if we draw right triangles, we can use our trig functions to make the convergence. We know that this is a positive 6. So I know my hypotenuse and I know this angle. How can I determine? I am wanting to determine my x and my y coordinate. That is what I am wanting. Well, if I know this angle and I know my hypotenuse, what trig function can I use to solve for x? Cosine, because cosine theta equals adjacent over hypotenuse. Well, I know my angle, cosine of 30 degrees, equals, I don't know my adjacent, that's my x value, and my hypotenuse is 6. So how do I solve for x? Multiply 6 to both sides. So basically x equals, do cosine of 30, then multiply it by 6. And that comes out to x is, I'm rounding to 1 decimal place, 5.2, because it's kind of hard to graph 2 decimal places on a graph. So that is one piece of my information to find my x value. So I need to find my y coordinate. What trig function can I use to find my y coordinate when I know the angle and I know the hypotenuse? Well, sine theta equals opposite over hypotenuse. I know my angle, 30 degrees. And by the way, I want my angle inside my triangle. That's the angle that I will use. Okay? I didn't need to know that angle right there in order to find my x and y value. I want my angle inside my triangle. So sine 30 is opposite as my y value over my hypotenuse, which is 6. Solving for y, I can multiply 6 to both sides. Those cancel. And then my y value is sine of 30 times 6, which that came out to, my y value is 3. So now I know that my x coordinate, write them in the correct order, x, y, and then my y coordinate is 3. But does this match my picture? No. So what quadrant am I in? I'm in quadrant 2. So when my x value here, is my x value going to be negative or positive? That's why it's good to draw a picture here. So since I went to the left, my x coordinate needs to be negative. So I went in the negative 5.2 direction. This negative tells you the direction. I went to the left. Then my y value is positive, so that can be a positive 3. So make sure your coordinates, you get the right signs on your coordinates that match with what quadrant you are in. Okay, so in the book, the solution will also be in radical format. So this is the same thing as negative 3 square root of 3. In my opinion, either format is fine. A decimal format or radical format. Where did this radical come from? Cosine of 30. So you can, for cosine of 30 and sine of 30, for cosine of 30, you can go put that in a ratio form. You know that from your special angles. So you can use the radical forms instead of putting it in your calculator. I vote for putting it in your calculator, but I'm just letting you know where do they get the radicals. They put this into a fraction form with radicals to get your answer in radical. Either decimal or radical is fine.